Hi, today we are going to discuss about circular queues. We know that queue is an ordered collection of data items into which elements are inserted from one end called rear end and elements are deleted from the other end called front end. Linear queues has some limitations in utilizing the space. The disadvantage of linear queues can be overcome with the help of circular queues. In circular queues, the first position is adjacent to last position. In circular queue, we use an array to store data items. Along with the data items, we maintain positions of front and rear. Along with front and rear, we maintain count of values or items available in the queue. So, circular queue is defined as structure of four members: an array, and front rear count. So we use four members as a structure to define a circular queue. Assume that there is a empty circular queue where a queue can contain a maximum of 5 elements. So there are 5 positions are empty, so it is an empty circular queue. This is the storage or array, and along with the array, we maintain front, rear count. Initial positions of initial values of empty circular queue is front is 0, rear is -1, count is 0. Suppose if I wanted to insert an element, insert 10 into an empty circular queue. Normally, we increase rear, and in the rear position, we place new element. But here we use rear plus 1 mod max q. Max q means here it is 5 max q. Rear is rear plus 1. Normally we use, and entry of rear is x. But here rear is rear plus 1 mod max q. Rear is -1 initial value, -1 plus 1 percentage max q is 5. Here the total number of element that we can enter is 5 elements. So -1 plus 1 is 0, 0 mod 5, which is 0. In the position of 0, we place our new element. Again you wanted to insert one more element. See here, once you insert an element, what happens to front? Front remains same, rear is 0, one element is inserted, so count of elements available in the queue is 1. Now, if you wanted to insert one more element, I wanted to insert 20, then again rear is rear plus 1 mod max q. Max q means total number of positions. So rear is 0, 0 plus 1 percentage 5, 0 plus 1, 1 percentage 5, 1. In the place of 1, we insert 20. Once you insert, count is increased by 1, count is now 2. So front remains 0, rear is 1, count is 2. Count is the total number of elements you have already inserted that are available in the queue. Then again, you wanted to insert one more element. Again, rear is rear plus 1. Rear is rear plus 1. Mod max q. Rear is 1. 1 plus 1, which is 2. 2 mod 5. 2. In the place of 2, 30 is placed, right? 10 is inserted, 20 is inserted, 30 is inserted. During insertion, front remains same, 0. Front is not changing, rear is changing. Then as you inserted elements, you are keeping track of the count of values available in the queue. So front is 0, rear is 1, count is 0, 3. For convenience, we are representing the circular queue like a linear queue. Here we assume that front first location is adjacent to last location, right? Just for convenience, we are cutting this array here and we are showing this like a linear queue, but we assume that the position 0 is adjacent to position 4. After 4, 0, right here. See here the same array. is represented here. The same Q is represented here. The same Q is represented here. The same Q is represented here. So instead of circular Q, we are showing it is just like a linear Q. So here see front is 0, rear is -1, count is 0. Empty Q, empty circular Q. Here count is 1, front is 0, rear is 0, count is 1. Front is 0, rear is 1, count is 2. Front is 0, rear is 2, count is 3. The same circular Qs we are representing in this fashion. Defining a circular Q. Circular Q can be defined as a structure consisting of 4 members. First one is array to hold elements of the circular Q. Second one is front to hold the position of front element or first element. Third one is rear to hold position of last element. And fourth one is count to maintain or to keep track of count of values that are stored in the queue. See here, there is an array which holds values, and along with this we maintain front, rear and count. Front is position of first element, rear is position of last element, and count is number of elements that are stored in the queue. The same is shown as a linear queue here. Of course, we treat that the first element is adjacent to last element. So this is a circular queue. So this is represented in C as a structure like this. See here, struct queue. It is a structure which is having an array. Array name is entry. This array consisting of max q number of elements. See here, in this example, we have taken a circular queue which can store 5 elements. So max q is a constant having 5 value 5. So entry max q entry is the array which can store a maximum of 5 elements. Then we have front, rear, count. Front is which holds the position of front element, rear is an identifier which holds position of last element, and count is the total number of elements. See here, in here there are 2 elements in the array or circular queue, so count is 2. Front is 0, rear is 4, count is 2. Front is 0, rear is 1, count is 2. Now inserting an element into a circular queue. Initially there is a queue which can store a maximum of 5 elements. Initially we assume that it is an empty queue, empty circular queue that too. First element is adjacent to last element. All are circular queues only. We assume that first element is last element. So every time drawing the circular queue is somewhat difficult. So we are showing it as a linear queue, but we have to assume that it is a circular queue where the first position is adjacent to last position. Then it is an empty circular queue. Front 0, rear is -1, count is 0. As there are no elements, count is 0. Then insert an element. You insert an element. See here, these instructions will get executed. Rear is rear plus 1 mod max q, where here max q is 5. Max q is 5. Rear is -1. Then plus 1, -1, plus 1. Rear is rear plus 1 mod max q, which is 0 mod 5, which is 0. In the position of 0, new element is placed. Once it is placed, count is increased by 1. See here, rear is changed, front remains same. Rear is rear plus 1 and count is count plus 1. Again you wanted to insert one more element. Rear is rear plus 1 mod max q, rear is 0, 0 plus 1 mod 5 mod max q. So new rear is 1 mod 5 1. New rear is 1. In the place of 1, 20 is placed. Count is increased. Front remains same. Again you wanted to insert one more element. Again rear is rear plus 1, 1 plus 1 mod 5, 2 mod 5, 2. Then in the place of 2, new element is inserted. Count is increased. Front is same. Then to insert 40, the same. To insert 40, 40 is inserted in the next position of rear. previous rear is 2. In the third place, what is placed? Count is increased. Again, you insert one more element. That element is inserted at location 4. Rear is 4, front is 0. So front is 0, rear is 4, count is 5. So there is a possibility of storing 5 elements. All the 5 elements have been inserted. Again, you wanted to insert one more element. Now the queue is full. Still, you are attempting to insert one more element. It won't allow you to insert an element. That's why it displays an error message, and the position of the status of queue remains same. See here, once queue is full, it is not possible to insert one more element. The new element will overflow and queue remains same. See, in the previous front is 0, here also 0, rear is 4, rear is 4, count is 5, here also count is 5. There is no change in the queue if queue is full. When queue is full, you wanted to insert one more element, it won't allow you to insert one more element. What is the condition for queue full? Because we are maintaining count. If count is max queue, if count is max queue, where max queue is 5, max queue 5. If it is 5, it is full. If it is full, it is not possible to insert. Otherwise, we execute these three statements. Rear is rear plus 1 mod max q. Entry of rear is x, where the array name in here is entry of rear is x, and count is count plus 1. Deleting elements from a circular queue. We consider the same circular queue which can store 5 elements. So 5 elements are inserted. Once 5 elements are inserted, the status of queue circular queue is like this. Front element is at location 0, so front is 0. Last element is at location 4, so rear is 4. Total number of elements are 5, so count is 5. So there is an array, and along with this array, we are maintaining 3 more data items: storage, front, rear, count. So it is a queue, it is a circular queue. So once we have a circular queue, we attempt to delete an element. Delete queue. Delete queue means it is trying to delete element from front end. So front element will be deleted. Front is at 0. 0th element is going to be deleted. Once you delete, front becomes next position. Front becomes 1. So because it is a circular queue, we use front is front plus 1 mod max queue. The next front is front plus 1 mod max q. Front is 0, 0 plus 1 mod max q. Max q is 5, 1 mod 5, 1. Next front is 1. Next front is 1. See, after deleting first element, 1 is the position of front. I'm not changing the position of rear. Rear remains 4, but count of elements is reduced. So count is reduced by 1. Count is now 4. Again, you wanted to delete one more element. Again, front element is removed. So first element is 20. 20 is removed, and front moves to next location. See here. So 20, two elements have been removed. 2 is front, rear is not changing, but count is changing because we are removing one more element, count is 3. Again, you remove one more element, see, next front is removed, front is moved to next location, count is count minus 1. Every time front element is assigned to x and front is moved to next location using front is front plus 1 mod max q, and count is reduced by 1. See here, there are two elements only. Next time you remove, front is 4. See, there is only one element. This is the first element and this is the last element. Front is 4, rear is 4, count is 1. Only one element is there. Again, you wanted to delete one more element. See, that front element is removed. Front moves to next location. Front moves to next location. 4 plus 1 mod max q. See here, 4. Front is 4. 4 plus 1 mod max q. 4 plus 1 means 5. 5 mod 5, which is 0. So front is 0. I'm not changing rear. Rear is 4. Count is 0. Yeah, earlier count is 1. Count minus 1. Count is 0. Front is 0. Rear is 4. Count is 0. Now again you wanted to delete one more element. But there are no elements in the queue. Queue is empty. Queue is empty. When you attempt to delete an element from an empty queue, it is not possible to remove any element, so it displays an error message. And queue remains same. Q is same. Front is 0, rear is 4, count is 0. How to find the Q is empty? If count is 0, Q is empty. Count 0. Count is 0. If count is 0, Q is empty. If it is empty, it displays an error message. Otherwise, it performs these three instructions. Every time you attempt to delete, it checks is Q is empty. If Q is empty, error message will be displayed. If it is not empty, an element can be removed. A front is changed and count is changed. Every time you insert, rear is changed, count is changed. Every time you delete, front is changed and count is changed. So while insertion count is increasing, while deletion count is decreasing, so we are keeping track of the count of values that are there in the circular queue. If count is total number of element, that is max queue, we say queue is full. If count is 0, we say circular queue is empty. We have seen how to insert elements and how to delete elements from a circular queue. Now let us discuss about the function to insert an element into a circular queue. Circular queue is treated as a structure having 4 members: an array, front, rear, count. So queue is, or circular queue is, a structure consisting of 4 members. Array. Here the name of the array is entry. The array can store a maximum of this many number of elements, max queue. What is max queue? Here it is 5. We are considering 5 is the total number of elements that can be stored in a circular queue. Then the type struct queue is redefined as CQ type, and Q is a variable of type CQ type. See, what is CQ type? It is struct queue. What is struct queue? It is nothing but 4 members. The entry, front, rear, count. Entry is an array. See the example. Example shows an array which can store 5 elements. So max Q is 5. Max Q is 5. Total number of elements is 5. Then there are 3 elements. First element is at position 0, that is front is 0. Last element is at position 2, rear is 2. Count is 3. Total number of elements that are there in 3. So the collection of array, front value, rear value and count value is nothing but your circular queue. Now you wanted to insert an element. Call the function insert. Insert q comma 40 means you are trying to insert a value 40 into circular queue q. You are passing reference parameter. Once you pass reference parameter in the function, it becomes a pointer. So see here, insert q comma x. You are trying to insert value x into circular queue q. So x is 40 right now. Then here, if circular queue is full, it is not possible to insert any more elements. See here the condition for full, circular queue full. If count is equivalent to max queue, what is count? Count is 3. Is 3 equivalent to 5? No. So else part will be executed. So else, there are 3 instructions. Rear is rear plus 1 mod max q. Entry of rear is x. Count is count plus 1. So first it changes the position of rear. Rear is rear plus 1. Rear is already 2. 2 plus 1 mod max q. Max q is 5. 3 mod 5. 3. Entry of rear is x. Entry of rear. Entry of 3. Entry of 3 is x. 40 is placed. Count is increased by 1. Count is already 3. 3 plus 1 4. See here. First element is at location 0. Last element is at location 3. Total number of elements are 4. Now again you wanted to insert one more element. Insert q comma 50. Now if you wanted to insert one more element, again execute these instructions. Insert q comma x. Now q is your circular queue consisting of 4 elements. X is 50. Now is q equivalent to max q? What is q? What is count? Count is 4. Is 4 equivalent to 5? No. So again these 3 statements will get executed. What is the Rear is rear plus 1 mod max q. Rear is 3. 3 plus 1 mod 5. 4 mod 5, which is 4. So rear is 4. Rear is 4. In the position of 4, you are trying to insert element. Yes, that element is placed in position 4. So front is 0. Front is not changed. Rear is changed. And in the place of rear, new element is placed. Count is increased by 1. Previous count is 4. 4 plus 1, 5. So these three statements have been executed. Rear is rear plus 1 mod max q. Element entry of rear is x and count is increased by 1, count is count plus 1. Like this, we can insert elements into a circular queue. Now, function to delete an element from a circular queue. To delete. So, we delete element from front position. For example, there is a queue consisting of 5 elements. It is a circular queue. Front is at position 0, rear is at position 4. Total number of elements are 5. Front is 0, rear is 4 and count is 5. We are trying to delete an element. X is delete address of q. So we are passing q reference. Once you pass reference parameter, automatically it becomes a pointer in the function. Q is a pointer. Q is having 4 members. Entry, front, rear, count. So Q is a circular queue which is having an array of elements, and we maintain front position, we maintain rear position, we maintain total number of elements that are already stored in the queue. Then, so here while deletion, every time you attempt to delete, you have to check whether queue is empty. If queue is empty, if there are no elements, if count is 0, means empty condition. If count is 0, when count is 0, queue is empty, there are no elements. If there are no elements, error message will be displayed. If queue is not empty, we can delete elements. That too, we can delete element from front end. Front element is assigned to x and front is modified. Count is reduced by 1. So here, where there are 5 elements and front is 0, you may delete element. Initially, we check what are count is count. Count is 5. Count is not equal to 0. As count is not equal to 0, there are elements. There are elements means we can delete element. So front element is removed. So 0th element is going to be removed and 1 becomes your new front and count will be reduced by 1. So front is 1, rear is not changing 4, count is reduced by 1. See here, front is at position 1, rear is at position 4. There are 4 elements in the queue. Again you wanted to delete one more element. X is delete address of queue. Now queue is a structure of 4 members, that too it is a pointer which contains entry, front, rear, count. If count is 0, what is count? Count is 4, not equal to 0. So these 4 statements will get executed. Entry of front is assigned to x, front is 1, 20 is assigned to x. Then front is changed, front is front plus 1 mod max q, front is 1, 1 plus 1 mod max q, 2 mod 5, which is 2. So next front will be 2. See here, front is 2, rear is 4, count is reduced by 1 and here one more element is removed. So now front is 2, rear is 4, count is total number of elements 3. Like this, you can reduce elements, we can delete elements from front position. Deleting element from front position is said to be deletion. Then to check whether a queue is empty or not. This is an empty function is empty. Empty function returns either 1 or 0. If it returns 1, it indicates that circular queue is empty. If it returns 0, it indicates that circular queue is not empty, because queue is a variable. It is a circular queue type variable where it maintains 4 members. Entry is an array, front, rear and count of elements. So we are checking count of elements. If count of elements is 0, it is empty. If count of elements is not 0, it is not empty. See here, at this particular stage, there is one element, count is 1. So the function returns 0. Here there are no elements, the function returns 1, count is 0, so function returns 1. Here there are 5 elements, function returns 0. Here there are 4 elements, function returns 0. Here there are 3 elements, function returns 0. Here there are 2 elements, function returns 0. So at any particular stage, it checks count of elements in the array. Because based on count of elements, it returns either 1 or 0. Only this is the place where there are no elements and circular queue is empty, so it returns 1. Check whether circular queue is full or not. So circular queue is full or not means it returns either 1 or 0. It returns 1 if it is full, if circular queue is full, all locations are filled with elements. It returns 0 if it is not full, if it is somewhat empty, right? See here, there is a possibility of storing 5 elements, only one element is there, 4 elements are not there. So there is still possibility to store some more elements. Now if you call useful function here, it returns you 0 because it is not full. See here, it is empty, it is not full. Here also it returns 0. See here, there is a possibility of storing 5 elements, all 5 elements are full, so there is no vacant space. So if you call useful function in this particular stage, it returns you 1. Here there is a possibility of storing 5 elements, so count is only 4, so it returns 0. Here count is 3, it returns 0. Here count is 2, it returns 0. Now let me explain what is the advantage of circular queue over linear queue. In a linear queue, for example, if there is a possibility of storing some 5 elements, store all the 5 elements like this. Here you wanted to insert one more element, not possible because pair is already reached its maximum position, so it is not possible to insert one more element. Delete one more element. Deletion means it deletes element from front element, so front becomes 1, rear is 4. If you wanted to insert an element, still there is not possible. So if it is a linear queue, it is not possible to insert one more element because rear reached its maximum position. Delete one more element. So here you may get this kind of position. Front is 2, rear is 4. Now you wanted to insert an element, it is not possible because rear is already 4. So rear is equivalent to max q minus 1. It will display an error message instead of inserting an element. Now see here, even though there is some space, so some vacant space is there, there is a possibility of storing 5 elements. Only 3 elements are there in the array. In a linear queue, it won't allow you to insert an element. But in a circular queue, we can efficiently use this space also. So here see, if count is equivalent to max q, what is count? Count is 3. If count is equivalent to max q, then only q is full. If q is not full, yes, q is not full. Q space is 5. There are only 3 elements, 2 spaces are vacant, so it is not full. So rear is rear plus 1, rear is 4. 4 plus 1 mod max q. What is mod? Mod max q. Max q is 5. 5 mod 5. 5 mod 5, which is 0. In the place of 0, you are going to insert your new element. Insert 60. At this particular stage, you wanted to insert an element. That element will be inserted at new rear. Rear is rear plus 1 mod max u. So 0. Rear is 0. Your front is 2 only. So front is 2, rear is 0. In the place of rear, you have inserted a new element. See once again try to insert one more element. Insert 70. So this is the status where rear is 0. Now rear is rear plus 1 mod max q. Rear is 0. 0 plus 1 mod 5. 1 mod 5. 1. In the place of 1, 70 is placed and count is increased. Every time you insert, count is increased. See here, there are 3 elements. You have inserted an element, count is increased by 1. There are 4 elements. You have inserted an element, count is increased by 1. But see here, what about rear? Rear is 4 and after insertion rear becomes 0. See, after 4 there is no space, but we assume that this particular circular queue is adjacent to 0 location. Next possible location is 0 only, so element is placed at 0 location. Once Once an element is placed at zero location, the next time you insert, next possible location is 1 only. So in the place of 1, an element is placed. In this way, you can utilize this space more efficiently than normal linear queue. So this is the advantage of using circular queue over linear.